Alright, so log functions. It's our fourth unit. So, a couple things we're going to do. We're going to talk about what we use logs for. Go over some basics with logs. I don't think any of us have seen logs before, have we? On your calculator, you've seen the button, but we've never actually talked about them and used them before. So this is the first time thing, so it might be a little difficult, might be a little out of our comfort zone. So, we're going to do all sorts of things. We're going to evaluate logarithmic functions. We're going to condense and expand. We're going to solve equations using logs, solve exponential equations, find missing values in a log equation, graph and identify exponential growth and decay, calculate compound interest, which we've done a little bit of already, and use change of base formula to evaluate an expression. So all that's going to get done in this unit. It is another long unit. It's 10 days from start to finish with an assessment, but there are a good amount of review days built in. Right? If you look, we see today we're converting exponents to logs, converting logs to exponents. Day 2, solving logs, stuff like that. We have a check-in on day 5, day 6, more practice. Day 8's log bingo. Day 9 is review. So we do have stuff built in. Our schedule that we're going to follow is not going to be the exact same on this paper here. Alright, I'm going to be gone next Wednesday and Thursday. I'm going on the DC trip with the 8th graders. Because they asked me to, so I said yeah. So I'm going to be gone Wednesday and Thursday, so we're going to kind of mix up a couple of our days where you guys might be playing like log bingo with the sub. You might do day 6 with the sub, and then I'll talk about condensing and expanding the day that I'm here. So it's a little bit easier. You're not going to miss anything new while I'm gone. That way it's a little bit easier for you guys to kind of go with the flow. Yes, Jalen?
What's the daily puzzle?
Daily puzzler, Violet.
Highway overpass.
Highway overpass. Right?
Oh, I didn't even see the way.
Ways up there,
I didn't see
yeah?
the way. I saw the pencil.
Alright, so that's our new unit. Let's get started right away. So first things first, why do we need logs? Why do we need logarithms? That first one says 2 to the x power equals 4. What should x equal? 2. Hey, you need to take your test. Finish it, yeah. Why don't you go sit in the back over your test? You checking with your study hall?
Yeah.
Perfect. Alright, so it's going to equal 2, right? 2 squared equals 4. Beautiful. What about 2 to the x equals 8? 3, right? 2 cubed equals 8. What about 2 to the x equals 6? Do you guys know that one off the top of your head? No, we don't. We don't know how to solve that. That's where logs are going to come in. They're going to help us solve these, get good answers for them.
Yes.
Right, the first 2 we can do right off the top of our head. We know 2 squared is 4. We know 2 cubed is 8. 2x equals 6 is going to be somewhere between those two numbers. So somewhere between 2 and 3. Right, it's got to be between those two. I don't know what it's going to be, but I know it's between those two. Right? 2 is equal to 4, 3 is equal to 8. So I know 6, when it equals that, got to be between there somewhere. So what we're going to do is we're going to use logs to help us solve those, right? Especially if we have something more complicated. 2.43 to the x equals 13,502. We're not going to do that in our head. We can't. Right? Well, if you can, then you're above my pay grade. But we don't know how to do that in our head. So logs are going to help us solve these. We need an undo way, we need an inverse, right? A lot of times we undo things. We want to undo multiplication, we do division. We want to undo subtraction, we do addition. If we want to undo an unknown exponent, right? Just like we had last unit, we couldn't find that exponent. An exponent's a variable, we are going to take a log. Logarithm or log is the inverse to an exponent. Alright, so that's why we need them. They're the inverse to exponents. And that's what we're going to talk about today, going from logs to exponents, exponents to logs. It's going to be a pretty easy day, I think. So, a logarithm is an exponent. Like we said, it is an exponent. In general terms, y is equal to log base b of x, or you can flip it around, you can write it the other way. Log base b of x is equal to y. Notice that b is below x. It is the base of the log. It's not b times x. So when we start writing bases, don't start writing it as log times b times x. It'll get confusing. Make sure we're writing it as a base. It's below there. If and only if x equals b to the y power. Now you're probably, that sounds really confusing, right? What that means, I can take this formula, this equation, excuse me, y equals log base b of x. I can change it to x equals b to the y. I can flip those around. I can maneuver. I can change it around so I can manipulate it so it looks like how I want. So, if we look at just like a normal problem here, we look at log base 2 of 8 equals 3. If I want to change that to an exponent, what's going to happen is the base of my log, that b term, my base, becomes the base of my exponent. So if I have a base of 2, my base for my exponent becomes 2. My answer for my exponent is going to come from what I'm taking the log of, and what it equals becomes my exponent. The more practice we do, the easier it'll be to remember that. Alright, right now it's going to take a little bit. You might have to look back at the formula, figure it out. So if I want to go the opposite way, I want to go from an exponent to a log. I have 2 to the 5th equals 32. It's a true statement. I just want to change it into log form. I'm going to take the base of my exponent, which is 2. That's going to be the base of my log. So I get log base 2. And I'm taking the log of my answer from my exponent. So log base 2 of 32 equals my exponent of 5. Right? If we look, all I'm doing is I'm taking b, which is my base of my exponent, becomes the base of my log. The answer to my exponent becomes what I'm taking the log of. My exponent becomes my new answer. So I'm just taking those variables, I'm flipping around, changing it into log form. These next couple days we're going to do a lot of going from log form to exponential. Exponential to log. The second one, 5 to the 0 power equals 1. We know that's true. Anything to the 0 power is 1. But I want to change it to log form just to see what it looks like. So I'm going to take log base. The base of my exponent is 5, so that becomes my base of my log. It's a really ugly 5. The answer is what I'm taking my log of. So log base 5 of 1 equals 0, or equals my exponent. Any questions so far? Okay. The next one. 10 to the 1st equals 10. I'm changing it to log form. So I get log base. The base of my exponent is 10. My exponent equals 10, so that's what I'm going to take the log of. And then my exponent is 1, so that's what my log is going to equal. Does that make sense? It's just using those formulas, manipulating our equations. Okay? Now, one thing to know, something that's really, really important. Anytime you see log base 10, that is what we call the common logarithm. That is our base logarithm. That log button on your calculator, that is always base 10. That is if you ever see a log without a base on it, right? This one says log base 10. It is a base of 10. It is our common log. It's the log that is used most often. So anytime you see a log of something, it doesn't have a base, that base is going to be 10. Alright? Vice versa, if you have log base 10 of x, you could write it as just log of x. That's our common base. Alright? Any questions? Good so far? Okay, let's try going the opposite way. Let's go from logs to exponents. Alright? So if I have a log base 10 of 0.1 equals negative 1. I want to change it to an exponent. So the base of my log 10 is going to be the base of my exponent. What my log equals is my exponent. So now it's 10 to the negative 1. And it equals what I took the log of, 0.1. Right? I'm going from log base b of x equals y to, b to the y power equals x. I'm just manipulating it. I'm changing it around. Alright? What's the second one going to be? I have log base 5 of 125 equals 3. Beth?
5 cubed equals 125.
5 cubed equals 125. Good. Right? The base of my log becomes the base of my exponent. what my log equals is my exponent, and what I'm taking the log of is what my exponential form should equal. Good. Last one, I have log of base 1/2 of 2 equals -1. So the base of my log, 1/2 becomes the base of my exponent. What I'm taking the log of, or excuse me, what log equals is my exponent, -1, and what I'm taking the log of is what it should equal. So it should be 1/2 to the -1 equals 2. A couple special log expressions. If I have log base b of 1, it will always equal 0. Log base b of 1 will always equal 0 because if you change it the opposite way around, or you change its exponential form, it comes out to b to the 0 power equals 1. And adding to the 0 power is 1, right? We said fire truck to the 0 power is 1. Anything to the 0 power is 1. So log base b of 1 is always equal to 0 no matter what my base is. Log base b of b is always equal to 1. Because if I change it to exponential, it will always be the base of my log to the first will always equal my base. Okay? Just a couple special logs. Any questions? Nothing? Alright. Keep going. So evaluating logs. The best way to evaluate log expressions is to change it into an exponential first. So if I'm trying to evaluate these logs, and we're doing this without a calculator, so we're going to try and do it by hand, doing it without a calculator, we want to change it into an exponential expression first. It makes it way easier. I don't want to do log base 2 of 8 in my head, but if I change it to an exponential, I can probably figure it out. So if I have log base 2 of 8 equals, let's say y, this equals a variable. I'm going to change it so it's an exponential. It's going to become 2y equals 8. Right? And the base of my log becomes the base of my exponent. What I'm taking the log of is what it should equal, and what the log equals is my new exponent. So I just let it equal a variable because I don't know what it equals. Well, 2 to what power equals 8?
3.
3, the third. So y equals 3. My original equation, log base 2 of 8, is going to equal 3. Alright? Log of 10,000. There's no base there. What's my base?
10.
10, right? We said any log without a base is 10. So once again, I'm going to let it equal an x, or a variable. I'm going to let it equal x. Right. Do you need a pass?
No.
No, you're good? Alright. So, 10 to the x equals 10,000. So what should x equal? Colton, what do you have up for? 4. So, x equals 4. Does that make sense? Right, we want you to try this by hand, guys. We want you to try it without your calculator. Alright, there's a bunch of them. I want you to try numbers 1, 2, and 3 right now. Try 1, 2, and 3. 4 and 5 are, and a few others after that are little special cases. We'll talk about that. Try 1, 2, and 3. Sure, if we're struggling, we're asking questions. Well, with about, let's say, another minute, and then we'll talk about it. Alright, let's talk about some of these. So we have log base 8 of 1 equals, I'm going to let it equal a variable. So I'm going to let it equal y. I want to change to an exponential. So base 8 to the y equals 1. Base of my log becomes the base of my exponent. What my log equals is going to be my exponent. So it equals my variable equal to what I'm taking the log of. 8 to what power is going to equal 1? 0, right? Anything to the 0 power is 1. So y equals 0. Good. The second one, log base 4 of 64. I want it equal x. So, base of my log becomes the base of my exponent. What my log equals should be my exponent. And what I'm taking the log of is what it should equal. So 4 to the x equals 64. 4 to what power equals 64? Third power. So x equals 3. Alright, log base 9 of 9 equals, let's say, z. So I get base of my log is 9. What my log equals is my exponent equal to what I'm taking the log of. 9 to what power equals 9? The first. So z would equal 1, or whatever you want to say equals 1. Alright. How did we do on those three? Good, so. Good. Not everyone's giving me an answer. Good. Do we have any questions? Alright, let's talk about the next one a little bit. It's a little bit different. Log base 5 of 1 over 25 equals, let's say what? It's a variable. Alright, so I'm going to change it to an exponential. So I'm going to get 5 to the y power equals 1 over 25. Right? Base of my log comes base of my exponent. What my log equals is my exponent. And what I'm taking the log of is what it equals. Now, what's different about this problem? Fuji.
A whole number to the power is equal to a fraction.
Yeah, now we have it equal to a fraction. We haven't had that yet. How do I get a whole number when I raise it to an exponent to become a fraction?
Multiply it times the negative exponent.
It's got to have a negative exponent, right? We talked about that. Anytime it has a negative exponent, it's going to get flipped to the denominator. So if I think about it, 5 to what exponent's going to give me 125? It's got to be negative 2, right? Because if 5 to the negative 2, that's going to be the same as 1 over 5 squared. So, I know y has to equal negative 2. Because 5 squared is 25, gives me 1 over 25. That's a great rule of thumb to have, maybe even write down. Anytime we're going from a whole number to a fraction, I know my exponent has to be a negative. It's a good thing to know. Let's look at the next one too. Log base 32 of 2 equals, let's say y again. So base of my log becomes the base of my exponent. What it equals is my exponent. And what I'm taking the log of is what it's equal to. 32 to the y power equals 2. Now you'll notice, look at all of our examples, not very often does the number we start with raising it to an exponent get smaller. Does it? This one does. I have 32 to the y equals 2. What type of exponent am I going to have here?
A fraction.
A fraction, right? It's going to be a fractional exponent because I'm going to take the root of something. So I now want to know 32 to some sort of fraction is going to give me 2. Well, the what root of 32 equals 2? The fifth root. So, if the fifth root of 32 equals 2, what does that mean my exponent's going to be? Not negative 5. That would give me a fraction as an answer. 1/5. So I know 32 to the 1/5 is going to equal 2. So y has to equal 1/5. It's another great rule to think about. When I'm going from a bigger whole number to a smaller whole number, I know my exponent has to be a fraction. Alright, I want you to try the next 3 now. Please. the last one, it might be helpful to change it from a decimal to a fraction. Might be. You don't have to though. We'll turn out those 3 problems. We got like one more thing to talk about. Make sure we're trying the problems. Don't just sit there. If you're struggling, raise your hand. If you struggle and I don't know about it, I can't help you. Do we need more time? We get ready to go? I see people still working, so we give a little more time. How you doing? Good? Page? Good? Number 10? So we know going from 2 fractions, I know what level that's one should be a fraction.
Oh, negative.
Negative. And the wall power is 1. Cube. Right, so yeah. So I know it's gonna have to be a fraction, right? And a fraction will turn into some sort of root. So the what root of 32 gave me 2? Fifth root of 32 gave me 2. So I'm gonna just let's see, I'm trying to calculate. Or you can think of it as like 2 to what power is 32?
So like 5 to
What power is 125? Okay, does that make more sense, Paige?
Yeah.
Okay. Maybe I should explain it. Alright, let's start going through them. So we have log base 9 of 3 equals, we'll say y. So I'm going to change an exponent. 9 to the y power equals 3. Going from a bigger whole number to a smaller whole number, I need what type of exponent? A fraction. I'm going to take a root, right? So the what root of 9 gives me 3. The square root or the second root. So I know y is going to equal 1/2. Right? So I want to take the square root of 9. Another way you can think of it is, if I know I'm taking a root of 9, I can think of, so the y root of 9 equals 3. Or you can think of it as 3 to what power equals 9? 3 to what power equals 9? 2. So I know if I want to go the opposite way, so if it's 3 to the second power equals 9, if I want to go the opposite way, I know the second root of 9 would give me 3. Alright, so if you need to, work it backwards. Just know that 2 will not be your answer. It's going to be 1/2 instead of 2. Does that make sense? Hopefully I didn't confuse you anymore. Alright, the next one. I have 125. Let this one be x. To the x power equals 5. Same thing. Bigger whole number to a smaller whole number. I'm going to need a fractional exponent. 125 to the what power will give me 5?
Or to the 1/3.
to the 1/3 power, right? 5 to the 3rd power gets me 125, so 125 to the 1/3 power will get me 5. Make sense? Alright, last one. For this set, log of 0.001 equals, we'll say x again, q. What's the base of my log in this one?
The base,
The base.
10.
10, right? There's no base here. It's going to be a base of 10. So, 10 to the x equals 0.001. Or you could write as 10 to the x equals 1 over 1,000, which I would rather see it as. Right? Makes it a little easier. I know I'm going from a whole number to a fraction. So what type of exponent should I have? A negative exponent. And I think about it, 10 to what power gives me 1,000? 3. So it's going to be 10 to the negative 3rd power gives me 1 over 1,000. So x equals negative 3. Okay? Any questions? Comments, concerns? No? Alright. One last thing I'm going to talk about. Evaluating logs on your calculator. So if you get your calculator out now and you type in log of 7, what do you get? You get 0. What? 854, right? Like that? Awesome. Or if you round it, you go like 0.85. Awesome. That's easy. Log of 1,000, what do you get? 3. Right? These are both log base 10. Log base 10. Those are easy. We know where that button is, right? It's right on our calculator. It should be right below our x squared button. That's easy when it's just that natural base, or that common base, not the natural base. We'll talk about that later this unit. But the common base. What if it's not base of 10? What if it's log base 2 of 256? We can't just hit that log button and do it. We have two different ways. If you have an older calculator, you'll have to do the change of base formula. If you have a newer calculator, you actually have a nice little button on yours. I'll show you that in a second. Before we get through though, the change of base formula is what you need to use if you have a base that's different than 10 and you want to put it in your calculator. So if I have log base b of a, I want to use the change of base. What's going to happen is I'm going to take log of a, so the log of what I'm taking the log of, over the log of b, or the log of my base. So like this first example, I have log base 2 of 256. I'm going to rewrite that in my change of base formula. It becomes log of 256 over log of 2. Right? Both of those have the common base. They're both bases of 10. And I'm going to go to my calculator and do it. So I'm going to hit log, oops, that's not right, 256 divided by log, what was it, 2? Hit enter. We should get 8. You all get 8? Awesome. So it equals 8. Same thing for log base 4 of 16,384. Make it log 16,384 over log base 4. Right? Do the change of base. Log of what you're taking the log of over log of your base. Did anyone get an answer for that one? 7. Awesome. If you have a newer calculator and you don't want to do that change of base formula, what you can do, go to your calculator, hit this beautiful little math button, go all the way down. Your A option should say log base with a parenthesis, hit enter, and you should be able to put in there what base you want. So if you want base 2 of 256, you can put it right in there, and it should give you the same answer. Either way, you're going to get the same answer. Use change of base, or use a nice base button. Either way, you should get the same answer. Alright? Any questions? Comments, concerns? That's it. That's all we got for today.
I have little.
Awesome. So...